Hello everyone, and welcome back to the AI Research Roundup. I am Alex, your host, and today is May 8th, 2025. Alright, today we are looking at a research paper from Hugging Face's trending list, published just about 9 days ago, on April 29th. It is titled, Beyond One Size Fits All, Inversion Learning for Highly Effective NLG Evaluation Prompts. This paper tackles the tricky problem of evaluating natural language generation systems. These are AIs that create human-like text. The core idea here is a method called inversion learning, which automatically generates effective, model-specific evaluation prompts by essentially working backwards from a model's output and its desired evaluation score, using just a single sample. Alright, so how exactly does this inversion learning create these prompts from just a single sample? Well, this first figure, it really lays out their process. On the left, we see inversion modeling. Here, they train an inversion model using something called supervised fine-tuning, which is basically teaching an AI by showing it examples of model outputs and the original prompts that led to them. Then, on the right, inversion prompting shows this trained model taking an evaluation example, like an article and its summary, and generating a tailored prompt, which then becomes a reusable prompt template. Okay, so after understanding that process, this table, Table 1, really shows the impact of their inversion learning. It compares how well different types of evaluation prompts perform across various tasks, like summarization and chat, using different AI models as evaluators. The key numbers here are the Spearman correlation and the Pearson correlation. These basically measure how closely an AI's evaluation scores align with human judgments, with higher scores being better. And consistently, their inversion prompts, the ones created by their method, achieve higher correlation scores, often showing substantial relative gain over other prompt types. Building on those strong correlation scores for their own prompts, this next table, Table 2, really highlights an important aspect: model specificity. It shows the results of a, quote, prompt swapping experiment. So they took an inversion prompt designed for, say, a llama model and tried using it with a QN model, and vice versa. Across various tasks, the Spearman and Pearson correlation scores generally drop when the prompts are mismatched. This performance decrease shows that their inversion prompts are most effective when used with the specific AI model they were created for. Following that idea of model-specific effectiveness, this figure, Figure 4, gives us a visual comparison of different prompt types used for a QN model on a question-answering summarization task. We see 3 panels: A forward prompt, which is a standard instruction-tuned prompt; B, a human-crafted prompt; and C, their inversion prompt. The colors highlight different parts like instructions and evaluation criteria. Visually, the inversion prompt often appears more detailed and structured, which likely contributes to its superior performance and model-specific nature we have been discussing. So, those visual differences we saw in the prompts really underscore the main findings here. It is clear that this inversion learning approach, it offers a really powerful and efficient way to automatically generate evaluation prompts. These prompts are not only highly effective, showing better alignment with human judgment, but are also specifically tuned to the AI model acting as the evaluator. This really challenges the idea of using one-size-fits-all prompts for assessing natural language generation systems. Thanks for tuning in to the AI Research Roundup, and we will see you next time.